Hello guys, welcome back. So in the last video we were discussing about how to write a cache for Fibonacci series. So let's try to add that caching technique to find what is the Fibonacci number of 45 in milliseconds. So I have to define one cache, int cache of some 45. Okay, this cache size will always depend on the value of n. Okay, in the program I will mention that n range will be from 1 to 45 only. Okay, so whenever I am giving a program, find the 45th Fibonacci number or 25th Fibonacci number, I will define the range of n in my program. Okay, so if n value is from 1 to 45, then the cache should be from 45 plus 1 because array starts from 0. Okay, the cache size should be 45 plus 1. Okay, if n value is 65, then my cache size should be 65 plus 1. So based on the n range and value, my cache size will differ. Okay, so currently I am now defining a cache of size 46 as the array starts from 0th index. So in my program also I am defining, I will ask you to find the Fibonacci number between 1 to 45 only. Beyond that I am not going to ask. So this is the my input that I am giving to the programmer. So in such case I have to define my cache as 46. Okay, if n value increases, my cache size will also increase. Now I have defined int cache of 46. Now I have to set up the cache. So for that I am calling set init cache. Okay, so cache is 0 to 46. Int I is equal to 0, I less than 46, I plus plus, and I am setting cache of value is equal to -1. Okay, I have defined the cache. I am initting the cache. So in this entire array I am filling it with -1. So that I am doing here. Okay, I am initting the cache over here. Before calling 45, I am initting the cache. Okay, I am setting the entire array to -1. Now what you are going to do, so whenever you are calculating any answer, okay, for any nth state, so here for example for any n is equal to 2, okay, you are calculating an answer saying f of 1 plus f of 0. Whatever the answer that you are calculating, you are storing here. For example, in future you might be asked to draw few diagrams. Let's consider I will ask you to draw a Mickey Mouse. Okay, so you will be drawing a Mickey Mouse, and again after 1 hour if I ask you draw a Mickey Mouse, okay, instead of drawing one more Mickey Mouse, you will get the Mickey Mouse that you have already drawn, right? So you are just saving the time over there. Instead of drawing again and again, you are just getting the painting which you have already drawn. Okay, in the same way you are calculating an answer over here. You are calculating f of 2 is equal to f of 1 plus f of 0. That answer you are storing it. So whenever I am asking again to calculate f of 2, instead of calculating, you are getting the answer what you have stored. Okay, so for any nth state, for any n, you are storing that value into cache. Cache of n is equal to f of n minus 1 plus f of n minus 2. Okay, and after the base condition you will write if cache of n not equal to -1. So initially we set cache of n is equal to -1, means nothing is there in the cache. Now here we have added one statement, cache of n is equal to f of n minus 1 plus f of n minus 2. So something is been stored in the cache. So when something is been stored in the cache, for that particular state answer is been calculated and stored in the cache. Okay, so again if you are being asked to calculate for that particular state, if again you are being asked to calculate f of 2, you have already calculated that value and stored in the cache. Okay, ideally if it is -1, nothing is stored in the cache. If it is not equal to -1, means something is been stored in the cache, and that is the answer, and you are not going to calculate that again and again. Okay, and you are returning that value instead of calling the recursion again. So this will save lot of recursions and lot of time, and it will give you the answers in milliseconds. Just see. So cache of 45, f of 45 is this number. So immediately we have got the answer. And if you observe the cache, okay, so it will store the Fibonacci numbers. Okay, cache of 2 is 1. Okay, second Fibonacci number is 1, third Fibonacci number is 2, fourth is 3. So like that it will store the nth Fibonacci number in the entire cache. Okay, so if you observe the cache data structure, it's an array, so it will give you all the what is the Fibonacci number. Eighth Fibonacci number is 21. Okay, so here the three important things is your cache size. So cache size will depend on the n. If n varies from 1 to 45, cache size will be 45 plus 1. If n is equal to 100, cache size should be 100. Okay, so I mean you can calculate that. So for example, if you want to calculate the 48th Fibonacci number, 48th Fibonacci number is very huge number, so it can't be stored in int data type. For that you have to use unsigned long int. Okay, so you need that cache, unsigned long int cache of 48, like that you have to define. Okay, that is secondary, we need not bother much. So this is the prime logic which we have to focus on. So if n is equal to 1 to 45, you have to define a cache of 46, and before calling the Fibonacci you have to init the cache. While initting, you have to set the entire cache to -1. Okay, and now you call the Fibonacci number. So for any state, whenever before you return, you just save the value into the cache, and then you return it. Okay, this will calculate the value, it will be stored into cache, and that value is been returned. So again, if you are asked to calculate what is the answer for that particular state, if the answer is already calculated and stored in the cache, don't try to calculate again, just return it from here. Okay, I hope you guys understood this one. This is nothing but dynamic programming. Okay, this is nothing but dynamic programming or smart recursion. Smart recursion means we are just saving another recursions. Okay, we are just saving the answer into the cache, and we are not calling the recursion again and again. We are just stopping. If the answer is calculated, we are not calling the recursion again. Okay, this is called dynamic programming or smart recursion, and this method of caching is called memoization. Okay, memoization or top-down approach. So we will be seeing few classical dynamic programmings solving with the help of memoization or top-down approach in the coming videos. Okay, you can find the code for this code explained in this video in the video description. Okay, see you in the next video. Have a nice day.